All right, today we are going to run through the Chapter 5, Honors Algebra 2, Chapter 5 study questions, getting ready for our test. The first topic we're going to talk about today is evaluating. This actually can be done without a calculator, but most of you can use a calculator. We don't want a decimal answer for these types of questions, but 125 is 5 to the third. That actually, when you multiply power to a power, gets you 5 to the negative fourth, which is 1 over 5 to the fourth, which is actually 1 over 625. Same thing with the next one. I'm going to change 81 into 3 to the fourth power. Multiplying power to a power, you end up getting 3 to the first, which is just 3. Remember, these questions I don't want a decimal answer, so 1 over 625, we want that in fraction form when writing your answer. Next one, we do want a decimal answer. Notice the direction says round answers to the 2 decimal places. You can write this as 30 to the 3/4 power. Let me try that again. You can write this as 30 to the 4/3 power on your calculator, or you can type it in as the cube root of 30 to the 4th, and you get 93.22. And the next one, same thing. You can write it just this way, or you can do 1 over cube root of 120, whichever way you want to type it into your calculator, and you get 0.20. And again, that's a calculator exercise, so being able to type those into your calculator. Next, we're going to actually solve. Isolate, so you're going to subtract 3, divide both sides by 2, and then take the 4th root of both sides. Anytime you take an even root of both sides, you always get a plus or a minus answer. And the 4th root of 8 is 1.68 using my calculator. Again, isolate. So I'm going to add 5 to both sides. Take the cube root of both sides, getting you x plus 2 equals 2.80. Now, because you took an odd root of both sides, you don't need the plus or minus. Subtract 2, and you end up getting x to equal 0.80. Last one in the group here, or I shouldn't say that, taking the 4th root of both sides. 4th root of 50 as a decimal is 2.66. Notice I put the plus or minus again, and you're going to add 1. Now, because we are actually finding this to the nearest decimal, you need to write this as 2 separate answers, 1 plus 2.66 and 1 minus 2.66. Now the last one in the group. Isolate. So I'm going to add 7 to both sides. Divide both sides by -3. Take the 5th root of both sides. Notice that I did not do a plus or minus because I was taking an odd root to both sides of the problem. Next, we're going to start simplifying. This is where in my class we did a factor tree. 2 times 40, 2 times 20, 2 times 10, and 2 times 5. We're looking for 3 of a kind. So I take out a group of 2's. Notice that I have 2 that are not part of the group. Don't forget the little cube root symbol, the index, when writing your answer. Now we have a fraction. So I have the cube root of 2 over the cube root of 7. You cannot have a radical in the bottom of the fraction, so you need to multiply. The question is, what do I multiply by? Basically, you have to figure out how many do you have and how many do you need. I currently have the cube root of 7. So then I need to multiply by the cube root of 7 squared. These two together make a perfect cube root now. So the cube root of 7 cubed is now just 7. And then you multiply across the top. You end up with the cube root of 98. Cube root of 98 does not simplify any further. You always need to make sure that you're cognizant of that. And so that is your answer. Same thing on the next one, multiplying both top and bottom by the square root of 5. I'm looking for a pair. I currently have 1, 5. So then I'm going to multiply by another square root of 5 to end up getting the square root of 15 over 5. Next, what happens if it's a binomial in the bottom of the fraction? You need to multiply by the conjugate and FOIL. So foiling the bottom, 3 times 3 is 9, plus 3 square roots of 2, a minus 3 square roots of 2, and a minus the square root of 4. The middle term will always cancel when multiplying by the conjugate, and then you'd basically have the first and the last, which gets you 7. Distribute now. 12 plus 4 square roots of 2. So again, anytime the bottom of the fraction is a binomial with a radical, you need to multiply by the conjugate. Next question is the same thing then. The conjugate is 7 minus the square root of 3. So I'm going to multiply both the top and the bottom by 7 minus the square roots of 3. 49 minus 7 square roots of 3 plus 7 square roots of 3 minus the square root of 9. Notice the inner and the outer both cancel, which means you're left with just the first and the last, and you end up getting 46. Distributing on the top, 7 square roots of 5 minus the square roots of 15. Neither one of those can be reduced, and I can't take anything out of all the terms, so therefore that is the answer. More simplifying. In order to simplify or adding and subtracting with radicals, you must have the exact same radical. So I'm going to try to simplify both of these. 56, 2 times 28, 2 times 14, 2 times 7. Group of 3 is 2. Cube roots of 7 times the 5 that was already out there makes 10 cube roots of 7. Same thing on the other side now. It's divisible by 3. 3 times 63, 3 times 21, and 3 times 7. Again, group of 3. Cube roots of 7 times the number that's already out there makes 6 cube roots of 7. And now, because I have the exact same radical, I can add the two terms together. All right, more simplifying, this time now with variables as well. I'm still going to do a factor tree for my number, and I'm looking for groups of 4 of a kind. So there are a group of 4 2s with a 3 left over. Notice I put a nice blank there because now I got to do each of the letters. There's 7 A's, which means I could take one group out with 3 A's that did not get part of a group. Remember, I'm looking for groups of 4 of a kind. So there's 5 B's. 1 B group gets to go out. 1 B has to stay in. And then 3 with no leftover C's. So 2AB C to the third cube root of 3A cubed B. Again, we got to deal with a fraction. Let's first talk about the bottom of the fraction. We'll get to the top in just a little bit. So we got the cube root of y. Remember earlier when we talked about the fact we got to decide how many we currently have, and we're looking to get a cube root. So I have 1y, so I need to multiply by 2 y's so that these two together would make a perfect cube root with just y. Now, the top is a different story. I end up with the cube root of 128, x to the 6th, y to the 2nd. I've done nothing wrong. It's just the top can be simplified. I'm going to come over here to the other side here. 128, if I did a factor tree for 128, I will notice that I have multiple groups of 3 of a kind. I have 3 of a kind in 2's, another 3 of a kind in 2's, which makes 4 with a single 2 left over. I have 2 complete groups of x's, and so my final answer, and I know I'm kind of put it in here right in the middle here, but my final answer would be 4x squared cube root of 2y squared all over y. If you ever get a variable on top, variable on the bottom, the rule is that you are allowed to subtract their exponents. This would be x to the 5/10 over x to the 6/10, which makes 1 over x to the 1/10. So now I've gotten it down to one variable. The trouble is I'm not allowed to have that 1/10 exponent. That's like having a radical. So I need to multiply by x to the 9/10. So that I now have x to the 1st on the bottom and x to the 9/10 on top. I do get asked a lot, why can't I go ahead and subtract again? Well, if I subtracted, I'd be right back to where I started here. So if I subtracted 9/10 minus 1, I'd be back to 1/10 on the bottom, and again, I don't want to leave my answer with a 1/10 exponent. Same question, multiple variables to deal with. 50 divided by 5 would be 10. Now, it doesn't matter how you want to deal with the x to the negative 1/4 over x to the 1/3. Some people say go ahead and move it to the bottom because it's a negative power and then add the exponents. Some say we go ahead and subtract them. Doesn't matter. You need a common denominator of 12. If you move it to the bottom or you subtract, you end up getting x to the 7/12 on the bottom of the fraction. And then the y's. Get a common denominator again. 15 is the common denominator this time. So I get 10/15 over y to the 3/15, which gets you y to the 7/15. Now, I can't leave the denominator with a fractional exponent, so I'm going to multiply by x to the 5/12. And here's my final answer then, x, 10, y to the 7/15, x to the 5/12. Next one, now we're going to graph. In order to graph with radicals, I got to pause for a second. I apologize for the disruption there. Getting back to graphing now, the first thing I need to come up with is what is the vertex. This is going to end up being a sideways parabola. The vertex value is when underneath the radicand is equal to 0. And so when I solve that, I end up getting x is equal to 2. That's where the vertex is going to be located. Then I continue from there. Pick numbers that are bigger than 2. So I could pick a number like 3, 4, 5. Again, some of these numbers are not going to come out very nice. I'm going to put in 6 just because that would be a little bit better. So now plugging in 2 for x, I end up getting 2. That is my vertex point. That's the most important point that I have. Other points now that I'm going to end up getting, 6 times 3 is 18. So I end up getting the square root of 12 plus 2. And again, that's an approximation then. You end up getting a little over 5. So again, all I need is just a couple of points here. 3. 5 works out very well. I should have used that one first. I end up getting 3 times 5, which is 15, minus 6 is 9. Square root of 9 is 3, plus 2, so I get the 0.55. And again, that next point is just a little bit bigger than that. And so I end up getting half a parabola going sideways. Talking about the domain, the x values you're allowed to use are any x value greater than or equal to 2. The y values, again, are greater than or equal to 2 as well. Looking at the vertex, that's what's going to tell you which way this goes. So from 2 going up on the x values, and again, from 2 going up on the y values. Another graphing question. We have to find the vertex, or excuse me, find the point for x that makes the value 0. This is because the domain is all real numbers and the range is always all real numbers because it's a cubic that we're graphing. Basically, I'm looking for the inflection points or when it's changing directions there. This one's a little more challenging. 9 is probably the best one to plug in. -9 is probably the best one to plug in because 3 times 9 is 27. Cube root of 27 is 3. Negative on the outside plus 1. I know I went through that quickly. -27 would be -3 with the negative on the outside, +3 plus 1. Use your calculator if you need to. And so when you're plugging in those numbers into the function, we get 0, 1, negative or +9, -2, and then -9, +4. And so it makes a zigzag shape going through the graph, and that's a cube root. Write the rule of G and describe the transformation of G. Let G be the horizontal stretch by a factor of 2, followed by a translation 4 units to the right and 3 units down of the graph. So the first thing I want to do is a horizontal stretch by a factor of 2. I want to take the original function. I'm going to replace x with a half x. Okay. Nothing to do with that one then, so I just leave it there. So I end up with the square root of a half x minus 2 plus 7. Again, doing these one at a time. Translation 4 units to the right. Again, I'm going to replace x with x minus 4. So now distributing there, I get 1 half x minus 4 because I end up getting minus 2 and then minus another 2 by adding like terms. And then the last thing it asked me to do was go down 3 units. And so my final answer here is g of x equals 1 half x minus 4 plus 4 on the outside. Again, my suggestion to many of you is to do these one step at a time and not to do multiple steps at the same time. Next one, I'm going to write a rule of g again. This time a vertical shrink by a factor of a half means I take the entire function times a half, which would get me 1 half square root of x minus 2 plus 7 halves. So multiplying both terms by a half. And then reflection on the x-axis again does the entire function, or changes all the signs of the entire function. So I'm multiplying the function by a negative sign. On your test, you're going to have to be able to write the rule of g based on multiple transformations. Solving again, isolate the radical. So I'm going to subtract 3, square both sides, and then solve the resulting algebra equation. Isolate the cube root this time, so I'm going to divide both sides by a negative 2. Cube both sides and solve the resulting algebra equation. More solving. This time it's going to get a little more complicated. You got to square both sides. Do not square individual parts of an equation. You must square both sides of the equation, which means I have a binomial that I need to square. Foiling that out, you get x squared plus 4x plus 4. Now, using my quadratic solving skills, I'm going to isolate. So I'm going to subtract 3x from both sides, subtract 10 from both sides. It does factor, and I set the parentheses equal to 0 so that I can solve. Now, with that being said, you always must check your answer anytime there's a variable outside the radical. Negative 3 does not work in the original question, but positive 2 does. So make sure you cross off the answers that do not work. Next, I have multiple radicals in the problem. I'm going to square both sides again, just like I did on the last one. The trouble is when I take the square root of x plus 1 times the square root of x plus 1 and FOIL, I get 2 square roots of x plus 1. So I still have a radical on one side of the equation. So I squared both sides. I FOILed out the right-hand side. So now I'm going to isolate the radical again. So I get 10 is equal to 2 square roots of x divided by 2 and solve. I end up getting x equals 25. So if you have a radical on both sides of the problem, you have to square both, or binomial on one side of the problem with a radical on the other side, you have to square both sides. The side that has the binomial, you're going to have to FOIL, and if there is a radical again, you have to isolate that radical when solving. Inequalities. Inequalities require one more step other than just solving it. You have to deal with the domain as well as the answer. So x plus 2 must be greater than or equal to 0. So this is the domain values that I'm allowed to have in the problem. Squaring both sides and actually solving it, I get x is less than or equal to 23. So now I have to combine these two when making my answer. It's greater than or equal to negative 2. It's less than or equal to 23. So the final answer is all the values between negative 2 and 23. Cube root. Well, remember, the cube root, the domain is all real numbers, so I don't have to worry about the domain anymore. Cubing both sides and solving, I get x to be greater than 132. Dividing both sides by a negative. Definitely on your test tomorrow, there's probably a question in which they will test to make sure that you remember the fact that when you divide both sides by a negative, you must switch the inequality symbol. So the domain value that I have to worry about is when 2x plus 6 is greater than or equal to 0. So x has to be greater than or equal to negative 3 is my domain. Solving the question, I end up squaring both sides, subtracting 6, and dividing by 2. So I have two things that I have to worry about here. I have to worry about my answer, which is x is greater than or equal to 29, and my domain, which is x is greater than or equal to negative 3. Now, if you think about that, here's negative 3, and we're greater than that, and here's 29, and we're greater than that. The area that's true for both is the actual answer. And so the actual answer is just greater than or 29 because that's the answer that is true for both. I don't have to worry about the domain because the answer took up the domain as well. Adding and subtracting functions. I'm given an f of x and a g of x, and I'm asked to add them, and I'm also asked to subtract them. So these are really two different questions here. If I wanted f plus g of x, I want to take the f of x function plus the g of x function, and I'm going to add like terms. Now, the order for one is different than the order for the other, so you got to make sure to add the correct terms together. The x squareds can be added together. The x's can be added together, and the constants can be added together. Order does matter. It's asking for f minus g. So again, order does make a difference. Negative 7x squared minus 3x plus 2 is your f of x function minus your g of x function. Please make sure you remember to subtract all the terms. So you got to subtract the 11, subtract the negative 5, and subtract the 1x squared. So I get negative 8x squared when I subtract. I get a positive 2x when I subtract, and then I get a negative 9 when I subtract. Next question is going to ask me to take two of them and multiply. Again, two separate questions here. I'm going to take 8x to the 1/3 times 2x to the 1/2. Whoops, I'm going to go back to my previous question here real quick. It did ask me to evaluate when x is negative 3. So we're going to plug negative 3 in for all the x's. So negative 6 times negative 3 squared minus 8 times negative 3 plus 13 and get negative 17. I'm then going to plug in negative 3 for all the x's in the second one here and get negative 87. Sorry about that. Going back to the next one now, I'm going to multiply. 8 times 2 is 16. Again, you're going to add the exponents, so x to the 1/3 and x to the 1/2. I get a common denominator of 6, so 2/6 and 3/6 make 5/6. So there is the multiplication. Plugging in 64 for x, I get 512. So there's two answers here, the multiplication and the evaluate section. Next, I want to divide. I get 8x to the 1/3 and 2x to the 1/2, which gives me 4 over x to the 1/6. Now going back to my rules before, I need to multiply by x to the 5/6 to simplify. So I get 4x to the 5/6 over x. So there's what it would look like. I am now then going to plug in 64 for x. So 64 to the 5/6 over just 64, and I'm going to get 2. Find the inverse of the function, then graph the function and its inverse. And notice that it has a restriction to the domain. So when I find the inverse, I have to worry about the domain as well. Remember, when finding the inverse, you take the x and the y and switch places. So here's the original question. There's what the inverse would look like. I then solve for y. Now, normally, I would say this would be a plus or minus the square root of x minus 5. But because the domain is only positive, I only did the positive value for the square root of x minus 5. Now let's talk about graphing. If I was going to graph the original question, remember my domain is 0 and better. So 0 and greater. So if I plug 0 in, I get 5. I plug 1 in, I get 6. I plug 2 in, I get 9. So graphing the original function, 0, 5, 1, 6, 2, 9. So there's the original function. Now, I could do the same thing down here, but I also know that the inverse will always have the exact same points reversed, because remember, you took the x and the y and you switched places. So 5, 0, 6, 1, 9, 2. Oops, I apologize on this one up here. I just noticed that I was off by 1. 2, 9. 6, 1, 9, 2. So there it is. And so you have a reflection or an inverse about the line y equals x. F of g of x, notationally speaking, this means you're putting the g function into the f function. So again, understanding the notation of this is more important than anything else. You're putting g into f, distribute, and add like terms. Next one, again, I'm putting g into f, a little more complicated this time. I'm putting 3x plus 4 in for all the x's. The 3x plus 4 being squared, I would need to FOIL that. So 3x plus 4 times 3x plus 4. Distributing the negative 4 and adding all the like terms. Next one, now they're asking you to just evaluate each one. So I'm evaluating at f is 3. So I'm going to plug 3 into the f function and get an answer of 11. And then I want the g of 11. So then I go back to the g function, plug 11 in for g, and I get negative 32. Now you'll notice the functions don't change, but the problems do. I want f of negative 4. So 2 times negative 4 plus 5. I get negative 3. Now they're asking me for f of negative 3. So they're asking me to plug it back into the exact same function. 2 times negative 3. I end up getting, so f of negative 3. Sorry about this. I got negative 6 plus 5. I get negative 1. And then the last one, g of negative 2. So I'm going to plug negative 2 in for the g function. I get 7. And then I want f of 7. So again, going to the f function, plugging 7 in, I get 19. And then I want h of 19. So now I'm using a different one, 19 squared plus 19 plus 6. And I get 386 when plugging 19 into the h function. Last question of the day. They want me to use composition of functions. I can't stress this enough. When they want me to use composition of functions, I have to do g into f, and also f into g. I will not give anybody credit if they don't show their work on this. So now let's put g into f. Putting x minus 5 over 3 into the f function. Notice the 3's cancel, then the negative 5's cancel, giving you a value of x. Now going the other way around, putting f into g. So now 3x, whoops, sorry. Notice the 5's cancel, giving you 3x. And so the answer to this is yes, because you get an x for both composition of functions. You must show your work or you will not receive credit. Last one then, I'm going to put G into F and F into G. Putting 1/2 x minus 3 in for x, I get x minus 6 minus 6, which is x minus 12. You can stop right there. This will be a no. You could do the other one. It would also get you x minus 6. So again, unless you get x for both composition of functions, then the answer is no. That concludes our review. If you have any questions, make sure to talk to myself or Mr. Bone, and good luck on your test.